Hey guys, this is the lesson or tutorial on volume of a sphere. Volume of a sphere, okay? So a sphere is a three-dimensional figure with all points the same direction from the center. So the radius is going to be in the center of the sphere, and it extends out, completely out on all directions, creating a sphere or a ball. So how do we find the volume of a sphere? Well, here is the formula. It's volume equals 4/3 times pi times radius times radius times radius, or radius pi, or radius cubed. Some of you might think, man, somebody's came up with that. Like, where did that formula come from? Well, I wanted to share this with you. And, again, if you're not interested, you can zoom forward to the example I give to you after this quick little tutorial. The example is going to be at the end of the video. So it's up to you. But I like to kind of show you the big picture of kind of where things come from and why and whatnot. So if you saw the other two videos, you noticed that the area or the volume of a cylinder is area base times height. And the area of a base, and that's going to be for pretty much any type of solid or prism for the most part. There's some exceptions, of course, but so the area of the base is pi r squared because it's a circle, right? So pi r squared is the area of a circle times height. That's going to get you the volume. For cone, it's the same thing. It's volume equals pi r squared times height, but it's 1/3 of that amount. So you could just divide by 3 at the end. And you could basically tell that basically these are all. And I basically try to create 3 similar cylinders, and I know they're a little wonky looking, but you could tell that the cone is smaller, okay? But it's 1/3 the size of a cylinder. Well, a sphere is going to be a little bit bigger than a cone. It's actually 2/3 of a cylinder, because the top part of the sphere is going to touch the top part of the cylinder here, and the bottom is going to touch the bottom. Now, what I did was I used the book's example here. Let's say that this was the radius, right? This is the radius and this is the radius. Let's say that the height of the cylinder is 2 times the radius. It's twice the length. So for example, let's say the radius was 4. If the radius was 4, the height would be 8. Okay, just think of a ball. So we just use 2r, so twice the radius. So height is twice the radius, 2 times the radius. So again, if the radius was 5, that means the height of the ball would be 10. If the radius was 6, the height would be 12. It's not always the case. Cylinders can be longer and whatnot. But again, this is just to show you how this all relates to each other and how this formula up here even occurs. Where does this come from? Well, this is basically the formula. It's 2/3 times area base times height. That's all it is. You could just go with this formula and be good. But I want to show you where this comes from. So let's say that the height is 2r. If the height is 2r, the 2r would go right here. The height is 2r, so it's 2r. Area base, again, so it's going to be pi r squared. It's the area of the base, or the area of the circle, right? The circle that you can't really see here. It's kind of inside there, right? So, which is the same thing as this one, obviously. And then 2/3 of that. So 2/3 times that. Now, combine like terms, so 2/3 times 2, right? 2/3 times 2 over 1 basically is what that is. It's going to become 4/3. Then you have pi r, and then r squared times r is r to the 3rd power. And that's where it comes from. So again, this is not, didn't come from thin air. Somebody just said, hey, I got an idea. I think this is it. Okay, this is where it comes from. So that's the concept of where it comes from. So sometimes I've seen people use, this is the formula. I have seen some people do volume equals 2/3 of base times height instead. Either one will work. Believe it or not, either one will work. It's just hard. It's hard to get height when you have no height. They don't give it to you. But you could do 2 times the radius. The diameter in this case could be the height, right? So I guess you could say 2/3 times base times diameter. But anyways, so we're just going to use this formula to kind of make things a little bit easier. Okay? So let's say we have an example. So an example would be, and I apologize for my lack of drawing ability here. I kind of drew this pretty quick. But let's say this is a sphere. Okay? And the radius is 11. So it's going to be volume equals 4/3 pi r cubed. So it's going to be volume equals 4/3 times pi times 11 cubed. So really the whole formula is going to be exactly the same. The only difference here is the 11. The 11 is going to, so that radius, that value for the radius is going to change for every sphere that you do. That's the only number you plug in. Everything else is going to be exactly the same as that. Every single sphere. Every single time. All you need to do is plug in the radius right here, and you're done. You solve it. So the way I do it is, instead of doing 4/3, because that could be like 1.3 repeating, and I don't want to do that. It's a little crazy. What I typically do is this. So I do volume equals 4 times 3.14 times 11 cubed divide by 3. And I don't know if you noticed what I did there, but basically I took 4/3, I multiplied, because everything's going to be over 1, right? Because this is going to be over 1, and this is going to be over 1 as a whole number. So it's going to be 4 times pi times 11 cubed divide by 3, and that's what I do. So this dividing by 3 occurs at the end, and 4 times all of that is going to go up front. So that's kind of how I do it. I kind of split it up. That way you can do it on the calculator, and you won't have to skip a beat. So on the calculator, I'm going to do exactly that. I'm going to do 4 times 3.14 times 11 times 11 times 11 equals, and then divide by 3. And I got 5,572.45. And I want to say we probably want to maybe round it to nearest, I'll do it in nearest tenths place. So volume is going to equal to 5,572.5 centimeters cubed. So that's it. That's the volume of a sphere. Okay? You want to write down the formula first. Write down this thing, then you just plug in your radius. Okay? And or you could just do it this way. Your radius obviously is going to go right here. So you can set it that way. You could just say every single time you see a sphere, just write down volume equals 4 times pi times radius cubed divide by 3. So that could be the formula right there. You could write it like that. And then change out the radius. So every time you get a different radius for a different sphere, plug it in, solve it, done. You can do it on the calculator. Hopefully that helps. I know this is very tedious work. There's a lot of little steps involved. The biggest thing is really just writing down the formula. Write down the formula, plug in your R, take a calculator, and just start at the 4, go to the 3, and you're done. Okay? That's it. Hopefully that helps. If not, please let me know. Email me. Let me know. I'll make a part 2, part 3, part 4, however many parts you need, and we will do a few more examples. So I try to make this as crystal clear as possible. All right, guys. Well, God bless. Godspeed, and I'll catch you in the next video.